Hello and welcome to another episode of This is Automation Live. We are excited to have you. Thanks for coming back, for tuning into this episode. We were really excited about our first live stream that we did on Tuesday on the rugged controls. And now we're kind of carrying that conversation forward to talk about the rugged PC platform from B&R. So that's a really exciting platform that kind of extends the existing mobile automation and off-highway platform to some really unique applications. So we're going to talk about what some of those applications are, where you might see that this rugged PC being used, and then we'll talk a little bit about the hardware kind of towards the end of the discussion, and the software tools and kind of software architecture that lends itself to these specific applications. So today we have a guest with us tuning in live. We have Adam Bennett. So we'll go ahead and get Adam called in here. So good morning,
Hello.
Adam. How's it going?
It's going well.
Awesome. So Adam is part of the sales team for B&R. He has a history with mobile automation and mobile machinery. So he, I know, is especially passionate about this topic and how our customers can use it to kind of take their business to the next level. So that's why we were excited to get him hooked up for this. So thanks for joining us, Adam.
Yeah, thanks for having me.
Good. So we will go ahead and kick the conversation off. Again, this is going to be focused on, to start with, the different applications that we're going to see this PC level computing required in rugged machineries, and then we'll talk a little bit about the hardware. So if you're really interested in the hardware, hang around and we'll get to that. But we really want to kind of lay out a map of where you would use this hardware so that you can really understand why the development decisions have been made the way that they've been made, and then we can kind of talk about how those software solutions fit in. So I'll go ahead and kick it over to Adam, and he will start sharing with us.
Yeah, this is an exciting topic to talk about. B&R has been developing their controls platform for 40 years, and with a focus on OEMs that are developing machine and typical industrial automation applications and robotics. Over the last, say, 5 years, B&R has really put a focus in bringing new products to market for what we call the mobile machine automation world, right? Like Corey was talking about. And in that world, there's just different requirements, mainly on hardware design, but also different software features that are required. But if we look at some of the applications like AGVs and mobile robotics, some of the big challenges that they're faced with is, their machines going into more outdoor environments and even cold storage environments, right? So think of food automation, food's processed, it has to be chilled or frozen in some cases. And in the warehousing operations, there's AGVs and robots, carrying out tasks in these environments. And the OEMs have to, with what they're given today on the controls environment, their controllers aren't designed to handle these environments, so they're applying larger heating elements around these controllers. And if you think about it, these controllers are in some sort of box, right? And the processor's in the middle of that thing. So you're sucking a lot of power out of the batteries to keep these things up to temperature to be able to run adequately. And now you're losing the life of the battery for your robots. So it's been a big problem that we wanted to address with the platform.
Yeah, and I think that's an interesting point that you bring up, that from a technology perspective, there isn't that big of a gap in what people want to do and kind of what's available as far as industrial PCs. There's a lot of capable platforms out there, but the real gap is kind of like you talked about on the environmental side. So being able to handle the shock and vibration, being able to handle the extreme temperatures, whether it's extreme hot or extreme cold. If you put an IPC in that situation with no additional protections, it's going to fall apart in short order. So really, being able to take advantage of the existing technology platforms that are out there and getting that into a ruggedized form factor is I think, like, one of the keys of the mobile PC platform.
Absolutely. Yeah. And then on these machines also, depending on the application, there's different levels of vision and AI that's needed for various tasks. right? Think of obstacle avoidance, object detection, path planning. These types of applications all require much more processing power than what your typical controls platforms have been able to provide. And to kind of expand what we talked about, right? It's also the environmental conditions that you're also dealing with. This goes into why we've developed this platform we're going to talk a little bit about today.
Yeah, exactly. And again, not to like beat this point to death, but with vision and AI, there is it's not perfectly available, but there are available solutions for vision and for AI. But a lot of them need pretty intense compute that you just can't get out of a traditional mobile controller, a rugged controller. And so that's kind of where the PC platform comes into play, to take advantage of the tools that are out there in maybe a more open PC architecture, instead of trying to fit those into a PLC architecture. And we'll talk a little bit about how those can combine together as well.
Yeah. And everything we've just kind of described there really bleeds into, autonomous and semi-autonomous vehicles, right? A lot of the same thing is happening, and we're seeing in the agricultural vehicles market, municipal vehicles, heavy equipment, construction equipment vehicles. They're all increasing those levels of autonomy, and to everything, kind of beating a dead horse, if you will, but much more processing power is required. And it needs to be able to withstand the environments, the shock, the vibration, the temperatures, but be able to host maybe a general purpose operating system that can run third-party software and things of that nature.
Yep, exactly. And I think a good case that can be made when you're looking at autonomy and semi-autonomy is this safety factor as well.
Yes.
Being able to automate some of these processes, like loading, like you see in the top right-hand corner there with the excavator, or some sort of plowing functionality in agriculture. When we can automate those, you can not only improve the efficiency of the process, but also the safety, especially in some of these, heavy machinery applications. So the other side of that, I think, is looking at, okay, we have all these great applications, but how do you kind of take those and continue to optimize and continue to improve? And that's where we have things like IoT, the IIoT in this case, or edge computing that come into play, where again, you want to take advantage of networking, advanced networking. You want to take advantage of cybersecurity. You want to take advantage of data analytics algorithms, maybe another use case for machine learning and AI. But that's just not available in a mobile controller platform. This stuff that's out there running machines isn't really capable of doing a lot of this. So again, being able to bring that into bring a PC platform into a rugged controls form factor can really bring a lot of value when you're looking at these kind of applications.
Yeah.
So moving to the hardware, how do we enable kind of all these different applications, whether we're looking at AGVs or vision processing, or autonomy and semi-autonomy, or edge computing, data analytics, those kind of things. We really think that the APC mobile platform is going to solve a lot of those problems. And basically the way that the architecture is laid out is kind of the same form factor as B&R's rugged controller, but the insides are different. So instead of a PLC inside, there is an Intel computer architecture inside. So we've got from Intel Celeron up to the Core i7. There's built-in heating elements. Adam, you brought up the issue of low temperatures. A lot of people think about high temperature specifications. How hot can I run this thing?
Right.
But there are also low temperature specs on all of these computer chips. Many of them around that 0 degrees. So what if I have my application in cold storage where I need to be running in minus temperatures, or maybe in an offshore wind application where I'm going to be in the middle of the ocean that's freezing cold? There are heating elements built into the APC mobile that can basically heat up the board to the required minimum operating temperature, and then send a command to boot. So basically a level of protection for the components in that way.
And a big point there is that it's going to be much smaller than what companies have had to do previously, right? Because it's built inside of the controller rather than being something that you're putting on the outside of a box. So there's going to be much less power being pulled to do something like that.
Yeah, exactly. So instead of taking an IPC and cramming it into a mobile machine, you're taking something that was designed for mobile robotics and mobile machinery. So it's going to be, of course, more efficient. It's going to be more cost effective. It's a simpler design, so on and so forth. The only other thing that's maybe of note on the hardware architecture itself is these boards at the back, very similar to the option boards if you watched the last episode, but these are actually PCIe boards, so you can add additional interfaces, things like that. If you needed some maybe additional Ethernet ports, for example, that can enable that. So it is still a scalable solution, not just in processing power, but also in the interfaces that are available. So I think a really important note is, okay, great. We know the use cases. We know the hardware is rough and tumble. It can get in there and do the dirty work, but how do you actually apply that at the software level? And I think where we see a lot of these use cases is with a hypervisor based solution. And for those of you that aren't super familiar with how a hypervisor works, it's basically a way to assign multiple operating systems to the different available hardware. So for example, if we're looking at an architecture that has automation runtime, which is B&R's real-time operating system, and then maybe Linux, which is a general purpose operating system, or GPOS, we want to run those on the same hardware. We can actually use a hypervisor to say, okay, automation runtime, you get one core of the processor, and Linux, you can have the other 3 cores. And same with the memory. Automation runtime here, you can have half or less than half, and Linux, you can have the rest. And then even down to the physical ports themselves. So if your Linux needs one Ethernet port and automation runtime needs one Ethernet port, you can actually assign down to that level. And so what that lets you do is basically combine the traditional functionality of a mobile controller and the advanced functionality that we've been talking about of a PC-based platform, all in the same form factor. So, where we see these architectures going is not, okay, I'm going to have my PC and my mobile controller. They're going to be kind of combined into one, in taking advantage of, Automation Studio and Automation Runtime for the control aspects. So kind of the traditional things that you would expect, controlling your IO, your control algorithms, etc. And then on the GPOS side, you would probably be doing the more advanced algorithms, maybe like your vision processing, or if you have some really advanced Simulink models that you can't run in automation runtime because of the computing requirements, you could run those in the Linux side as well. And then set up virtual network connections or shared memory locations to communicate back and forth between Linux and automation runtime. So it's a really powerful way to architect your system to take advantage of kind of the traditional way you've been controlling your machine at the controls level, the IO level, and take advantage of the new, edge computing, data analytics, machine learning, all of those different things. Good. Yeah. So that is our very quick introduction to the APC Mobile. So an important part of that we mentioned was Automation Studio and Automation Runtime. We're actually going to be diving into a quick introduction to Automation Studio in the next episode, which is going to be going live Tuesday, March 31st at 10 a.m. So that's next Tuesday. So make sure you subscribe to that if Automation Studio is something that you want to learn a little bit more about. And yeah, we're going to be diving into the actual software. It's not just going to be slides. So if you're someone that likes to get kind of down in the weeds, that'll be exciting for you, I think. So we've got a good guest lined up for that one as well. So I think my big takeaway, Adam, from the discussion is there is a gap in the market right now for these use cases that require a lot of compute. And there's just not a product that can really fill that. And even if there is a product that kind of works, there's a requirement to package it, to add heaters, all these different things that can drive up cost, increase in complexity, increase service costs, those kind of things. So really what the market is looking for is a way to combine these advanced functionality with the kind of traditional automation functionality in one rugged box. And I think that the APC Mobile is really bringing that to the market, and we're already seeing a really, really good response from the market on this product. and the capabilities that it can bring. Any final words from you, Adam?
Yeah, I think the only thing I would add to this is really about when companies are looking to partner with a controls company, it's really about the full platform. So I'm excited that you've got the next one is about Automation Studio, the software platform. That side of it, I feel like software is can also be more important in a lot of cases than just the hardware itself. And so, everybody watching, if you want to learn more, certainly tune in on that one. But also, the other key point is when you're partnering with a company, it's about lifecycle management. When it comes to the hardware and the software, I think it's important that is something that companies take a deeper dive into and look at, right? You want to ensure that whatever you're developing is something that you can support and your vendors can support over the life of the machines, right? A decade or longer.
Yep, for sure. Great points. Thank you, Adam, for joining us. We really appreciate you making the time to join the conversation.
Yeah, thanks for having me.
Yep. So to wrap us up, thank you everybody at home watching as well. Hopefully you're at home, not at work right now. And we really appreciate you tuning in. If you have comments, questions, feel free to leave a comment on the video, or you can reach out to either myself or Adam on LinkedIn. I'll make sure to leave the links to that in the description of the video. And if you enjoyed the video, give it a like. Make sure you subscribe to the channel so you can get all of the next live streams. Set your notifications for the live streams, and we'll be talking to you soon. Thanks for watching.